Okay, welcome to today's lesson on complex numbers. What we're going to see today is that there's in fact a third way that you can write a complex number. Previously, we had looked at rectangular form and polar form. Well, this new form, this third type, is actually called exponential form because there is an exponent involved. Here is what the number looks like. You have r, which again is the length of the radius vector to the complex number if you were to draw the graph of it. E is the base of the natural logarithm. You don't have to convert that into anything. You don't have to evaluate it. You just write your E. You have your j then in the exponent, and that's the square root of -1. That's the imaginary part. But then you have the symbol theta for the angle. Now, it's the same angle that you have in the polar form with one big difference. If you write the complex number in exponential form, theta, the angle, must be in radians. So if you think about that carefully, the only real calculation required to change from polar form to exponential form and vice versa is to convert the angle. Convert from degrees to radians or from radians into degrees. And you saw how to do that in Math 1700. If you're converting from, from radians into degrees, here is your conversion factor. In other words, you multiply the number of radians by 180 degrees over pi. If you're converting from degrees into radians, you multiply the number of degrees by pi over 180 degrees. For that calculation, sometimes you could even leave it in exact form if you wanted to, involving the pi, or you could write it to a decimal. If you're going to convert to a decimal, make sure you use at least 2 decimal places for radians. And the reason for that is radians they're pretty big. 1 decimal place for radians is actually still quite a bit of error. So you want to go to 2 decimal places for radians. Let's look at example number 11. This is on page 21. And the first thing you're asked to do is convert from exponential form. And I can clearly see that examples A and B are both in exponential form. They want us to convert into rectangular form and also into polar form. We have to do 2 calculations for each one of these. The obvious thing to do, the simplest thing to do, would be to convert into polar form first, because the number in front, remember, that's your radius vector anyway. That's your r. That's the length of the radius vector. So r is 2.00 in the first example. I see my e. That's the base of the natural logarithm. I look at the exponent. I see the j, and I see 4.80. That 4.80, that's your angle, but it's in radians. If you want to convert it into polar form, that must be changed into the number of degrees. So let's do the calculation. The number of degrees is equal to 180 degrees divided by pi multiplied by 4.80. So just type that into your calculator. And now, because you're converting into degrees, 1 decimal place is enough for degrees. And if you type that in, I get 275.0 degrees. So we can now write the polar form of this complex number. That's the only calculation that was required. R is 2.00, and then your angle symbol, 275.0 degrees. So there's your polar form. All done. And it's actually that simple. But there's a second part. We have to change it now into rectangular form, which means rectangular form, recall, is your a plus bj, b times j, j being the square root of -1. So to calculate your a and your b, well, that requires those 2 formulas that we used previously. A is equal to r times cosine theta. So in our case, that's 2.00 times the cosine of 275.0 degrees. Make sure your calculator is in degree mode for that, by the way, when you do that. And I get 0.17. That's my A. B is equal to R times the sine of theta, which in our case is 2.00, times the sine of 275.0 degrees. And I get for that negative 1.99. So there's my A and there's my B. So in rectangular form, I'll just write it here. The number in rectangular form is 0.17 minus 1.99. And don't forget the J for the B part, for the imaginary part. So there you go. We've changed that number into polar form and into rectangular form. It was given to us in exponential form. Now the calculation for part B is exactly the same. There's no difference. The first thing I would do is write that one in polar form. You can see that your R is a big number, 464. Well, that's it. You deal with the 464. But your only calculation would be to change 1.85 radians into degrees first. That will give you your polar form. And then do a similar calculation for A and B here, and that will give you your rectangular form. So I'll leave that one for you to try, as well as the practice on the bottom of page 21, right there. All right, so you try those. Remember, the solutions are all posted on D2L. Make sure you have a look at the solutions to see that you're doing them correctly. All right, so let's go ahead now. And let's look at the examples that are on the top of page 22. Now, these look similar. These are somewhat the same. But now they're asking you to convert it to exponential form. So A is given to us in polar form. B is given to us also in polar form, but it's the extended version, the longer version of the polar form. But I can still see my R, no problem. And I can see my theta is 60 degrees. That's no problem. So I can convert there easily. C is in rectangular form. There's a little more calculating involved to that one, but we'll go ahead and do that one as well. So here's our first part. Let's look at A. R is 8.50. No problem. That's my R. That's going to go in front of the exponential form as well. The only thing I have to do is convert that angle right there, which is in degrees. I have to convert that into radians. So here's my only calculation that I really have to do. R is equal to pi over 180 degrees multiplied by 136.3 degrees. Okay, make sure you write the degree symbols for degrees, by the way. Now, if you work this out, and round it to 2 decimal places, because remember it's radians. Radians are big. You have to use at least a couple of decimal places. I actually get 2.38 radians. So that means that really I can just write it in exponential form here now. That's all the question is asking you to do, change it to exponential form. So the angle is going to be, or the number is going to be 8.50, that's my R. E, and then 2.38J. There you go. There's your exponential form right there. That's your answer. And that's all the question asked me to do, was convert into exponential form. B, same problem, same calculation. You have to convert it into the angle, 60 degrees, into radians first. Now that one you can also, if you wanted to, you can leave that exact. So pi over 180 multiplied by 60. Well, 60 over 180, you see, is 1/3. So that's pi over 3. If you wanted to leave it exact, that is. Or 1.05 radians. Either way would be fine. So the answer in exponential form is just 3.00 e to the power of 1.05j, like so. Or if you wanted, you could have called that e to the power of pi over 3 times j, same thing. Okay? Now let's look at C. This is a little bit longer of a calculation because here we have to calculate r, and we also have to calculate the angle. Now you can calculate the angle in radians right away if you put your calculator in radian mode. That's up to yourself. So here's how we calculate r, remember? Square root of a squared plus b squared. So we're going to have the square root of 5.90 squared plus 2.40 squared. Type that into your calculator, and you should end up with, I get 6.37. That's your r, remember. That's what goes in front. Now for the angle, remember the first thing you have to do is calculate the reference angle. And that means that theta is going to depend on which quadrant the angle ends up in. Well, 5.90 is positive, 2.40j, that's positive. So this angle, this number would end up in quadrant number 1, which means that the reference angle you calculate actually is going to be theta in this case. Or it's going to be the same. So we can just merely go ahead and go theta is equal to the inverse tangent of b over a. B over a. So that's the inverse tangent. Now remember, if there were any negative signs here for a or b, I would drop them. So there's 2.40 over 5.90. Now remember, you want the angle, yes? But if you put your calculator in radian mode at this step and do the inverse tan of that ratio, you're going to get the answer in radians anyway. There would be no need to convert them from degrees into radians. I get, according to my calculation, 0.39 radians. So that means that the number here in exponential form, so exponential form is, let me see, 6.37. Angle symbol. Oops, sorry, no angle symbol. Wrong. I'm putting it in exponential form, remember. So I put my e to the power of 0.39j. There's your exponential form. Okay? Practice on the bottom of that page I'll leave for you to try. There's one other thing I want to look at in today's lesson, and that's multiplying and dividing complex numbers in exponential form. This is incredibly simple. This makes it obvious why the rules that you learn for multiplying and dividing in polar form must work. I mean, even if I just wrote down a couple of regular monomials, if you're multiplying 5x squared times 3x to the 7, how would you actually multiply that? What would the answer be? Well, you'd multiply together the numbers in front. That would give you your 15, and then you have your x, and you would add the two exponents. Right? I mean, that's the rule you've learned for a long time, so that would become x to the power of 9. And that's exactly the same as the rule for polar form. It's exactly the same as the rule for exponential form. Well, let's look at a couple of examples right here. We're going to have one multiply and one divide. So 4.2 e to the power of 1.15j is multiplied by 8.5 e to the power of 2.40j. You actually multiply the r's, and you add together the two powers. So really, there's no calculations here to show. Just take your calculator, multiply 4.2 by 8.5, and you're going to get 35.7. And then your e, and now just add together 1.15j and 2.04j, and you're going to get 3.19j, and that's all there is to that. There you go. It's really easy, and it explains why the rule works in polar form. Here you're dividing two numbers that are in exponential form. So again, you divide your r's. 6 divided by 2 is 3. E to the power of, and now you just subtract the two exponents. You subtract the two powers, which is what you would do if they were x's. You use your subtraction. And I get 1.62j. And it's as easy as that. Okay, so you try the practice ones on the bottom of that page. We are out of time. Bye-bye for now.